Alright, hey, this video is aimed at teaching you all about rectangles. So recall that we're working with definitions, and then from the established definition verifying properties, and then using those definition and properties. So a rectangle by definition is essentially, it's a special type of parallelogram. It's a parallelogram with one right angle. Now, actually there are more than one right angle, but the definition that we're going to use is all we need is one right angle and a parallelogram. So a right-angled parallelogram is a rectangle, and so it looks like this. So if we have one right angle there, and these have to be parallel, well, ooh, gosh, that has to be right too. And if, ooh, these have to be parallel as well because it's a parallelogram, then, ooh, all the other angles have to be 90 as well. But that's the definition for now. Parallelogram with one right angle. Okay, and since it's a parallelogram, we have some properties to establish, and all the parallelogram properties are inherited because, you know what, a rectangle is a parallelogram. So the diagonals bisect each other, opposite sides are congruent, parallel also by definition. Opposite angles congruent, and consecutive angles are supplements. So all of those properties of a parallelogram are inherited within this rectangle because, you know what, rectangle is a parallelogram. So in addition to all those properties of a parallelogram, we have a couple more that come with a rectangle. And so those are the ones we're going to focus on now. If we have one right angle and it's a parallelogram, well, remember, one of the properties is that these consecutive angles here of a parallelogram, and also of a rectangle, because a rectangle is a parallelogram, these consecutive angles have to be supplements. So if this guy's 90, then, oh, lo and behold, that guy has to be 92. Oh, so that's got to be 90. And you know what? Remember that opposite angles have to be congruent too. So oh, if that's 90, yep, this guy up here has to be 90 as well. And similarly, these opposite angles of the parallelogram, really a rectangle, but a rectangle is a parallelogram, these opposite angles have to be congruent too. So if that's 90, that's got to be 90 as well. So really we have all four angles are right. Okay, and we can establish that just knowing that it's a parallelogram with one right angle, and that therefore shows us that all four angles have to be right, and that's a property. Okay. So what I'm going to do to establish the next property is I'm going to give you a little coordinate action. So I'm going to set up a generalized version of a rectangle, and we'll call that 0, 0. That's always a nice point to use. And I'm just going to move up along the the y-axis. This is the x, that's the y. A units. So we want to be general, so I'm going to name that point 0a, and then I'm going to move over b units, so that point becomes b, 0, and then in order to be a rectangle, this piece right here, that point, has got to be over b and up a, so that's the point BA. So what I just did was I established a generalized rectangle on the Cartesian plane. What I'm going to do is establish the final property using the coordinate geometry approach. And so the final property has to do with the diagonals. So there are two diagonals, 1 and 2. And what I'm going to establish is the third property of a rectangle, namely that the diagonals are congruent. So the diagonals are indeed congruent, and I'll show you why that works now. And I'm going to use the coordinate approach. So what I'm going to do is go back to my generalized version of a rectangle plopped onto the Cartesian plane, and to show diagonals congruent, I'm going to use distance formula. So let's kind of ignore this guy for now. Okay, and we're going to focus on that one diagonal. And so to find the length of that diagonal, and let's give it a name, we'll call it D1. So that diagonal D1 is going to be in length the square root of, using the distance formula, the differences in the x's, so it's b minus 0 squared, plus the differences in the y values, a minus 0 squared. Okay, and after a little simplification, b minus 0 is just b, and a minus 0 is just a, 1 squared. And recall that you can't pull each of these out. It's not b plus a because of the plus. You can't do that. It's illegal. There's essentially an implied parentheses under here. So you have to work within the parentheses first before you pull those b's and a's out. And you cannot do that with the addition or subtraction here. Okay, so that's the length of this diagonal here, the square root of b squared plus a squared. Now normally that wouldn't sit, that wouldn't be cool, but let's kind of think about what the other diagonal is going to look like in length. And I'll call that diagonal's length d2. And that second diagonal in length, and I'm going to kind of ignore this diagonal for now, d1, so we can focus in on the second diagonal. In length, using the distance formula, it's going to be the square root of the difference in the x's, which is 0 minus b squared, plus the difference in the y's squared, a minus 0 squared. Okay, we're going to clean that up. And of course, 0 minus b is negative b, but when you square negative b, you can just get plain old positive b squared. And then a minus 0 is a. We square that to get a squared. Okay. Ooh, and lo and behold, both the diagonals, there's my d1 back in action, have the same lengths, square root of the quantity b squared plus a squared. Therefore, diagonals of a rectangle must be congruent. And this is a way to prove things a little differently using coordinate geometry. We use a generalized version of a rectangle with these vertices. Okay, I urge you to think about how you know for sure that this is indeed a rectangle. It is, for shizzle. And here, therefore, are the two lengths of each of these generalized diagonals. This guy is square root of b squared plus a squared. And that guy is also the square root of the quantity b squared plus a squared. So to conclude, here's a definition of a rectangle. It's a parallelogram with a right angle. And the properties include, if there's one right angle, there's got to be 4 right angles. Okay, and also if it is a rectangle, the diagonals must be congruent. Thanks for listening. Have a great day. We'll see ya. Bye-bye.